Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we will focus on the definition and semantics of a virtual method declaration. Is virtual of value? Declaring a method in a parent class and then providing a different implementation in a child class is a fundamental principle of object-oriented programming. C++ has more flexibility in method declarations, which is not available in languages such as Java or Ruby. This can be either a plus or a minus, depending on your point of view. The keyword virtual has one specific meaning, which sort of implies it should be easy to use and simple to understand. But this is C++, and we need to look a bit deeper. Where can the virtual keyword appear, and where does it have no meaning? Can it lead to undefined behavior? Can virtual be used with special member functions? We are going to look at these questions and then talk about when and why a virtual destructor is of value.
There are two places the virtual keyword can be used: in a method declaration and when declaring an inheritance relationship. We are going to discuss declaring virtual methods. When a method is declared as virtual, then any implementation with the same name and signature in lower levels of the hierarchy will automatically be declared as virtual. There is no need to repeat the virtual keyword in a child class. Every child or grandchild implementation is called an override of the parent class virtual method. The key purpose of virtual methods is to control how the compiler chooses which implementation for a given method should be invoked. When a method is not declared as virtual, the compiler must select the implementation at compile time based only on the declared data type. In computer science terminology, this process is often referred to as early binding or static dispatch. If a method is virtual, the compiler must defer the decision until runtime, when the actual data type of the object is known. This is called late binding or dynamic dispatch. There is a small runtime cost for late binding, because the runtime system must look up which method to invoke. This cost is the main reason why late binding is not the default for method calls in C++. When a method is redeclared in a child class without being marked virtual in the parent class, this is called method shadowing. A call to this method will be resolved at compile time and is referred to as early bound. If the base class method is marked virtual, then the child class method is an override, and any calls to the base class method typically need to be resolved at runtime, which is late bound. So the only difference between these two cases involves the declaration of the method in the parent class. In this example, shape is the parent class, and triangle is a child class. The draw method is declared in shape and may be redeclared in triangle. Our variable has the data type pointer to shape. However, the pointer actually points to a triangle object. If the draw method is shadowed, then the implementation in shape will be called. If the draw method is an override, the implementation in triangle will be called. Looking at just the code we are showing does not provide enough information to determine which implementation will be invoked. To figure this out, you would need to look at the definition of the shape class. None of this is a defect or undefined behavior. Shadowing and overriding methods are both fully supported in C++.
Before we can talk about virtual destructors, we first need to define exactly how destructors are declared and what they do. A destructor cannot be const, static, or volatile. C++20 added the ability to call a destructor at compile time, so they needed to allow the ability to mark a destructor const_expr. At the same time, destructors were enhanced to support a requires clause and a template constraint. A destructor can be defined using =delete to prevent objects of that class from being destroyed, or it can be marked with =default to request that the compiler generate an implementation for you. If no destructor is declared for a given class, the compiler will try to generate one automatically. If the compiler cannot generate a valid destructor, then the compiler will automatically delete the destructor for the given class. This might happen because one of the data members in the class is not destructible. The sole purpose of a destructor is to clean up the resources which belong to that object. This occurs when the object's lifetime ends. For a local variable, the lifetime ends when it goes out of scope, and the destructor will be invoked automatically. For an object allocated by calling the operator new, the lifetime ends when it is destroyed by calling the operator delete. The delete operator does two separate things. First, it invokes the destructor, and then it will free the memory which was allocated on the heap. When creating new objects, the constructors are called in order from parent to child. Looking at our example, the fruit object is constructed first, and then the apple object is constructed. Destructors are called in the opposite order. The apple object will be deleted, and then the fruit object is deleted. The ordering of constructors and destructors would be the same if apple were created on the stack and not the heap. This code is a bit sneaky, since it might look like the call on line B invokes the implementation in apple, but that is not what will happen. In this code, the method doSomething in fruit will be called. Notice the method is not marked virtual in fruit, which means the implementation in apple is a shadow and not an override. The virtual in the declaration of apple is a bit misleading and actually does nothing in this code. The code on line C calls delete, which will invoke the compiler-generated destructor in fruit. This causes a problem, and we will explain why in a moment. But first, it is worth pointing out that it is valid to call a destructor directly rather than using delete. The syntax is strange, and the result is not usually what you want. The code would be item arrow tilde fruit open paren close paren. When calling this destructor, the object is destroyed, but the heap memory is not released. Please be careful if you choose to do this.
Virtual constructors are not allowed. If you think about it, what would a late-bound constructor even mean? In order to construct an object, the compiler needs to know the exact data type of that object. This is not something that can be deferred to runtime. On the other hand, destructors can be virtual, and in fact there are times when it is required. Remember, a destructor is responsible for cleaning up resources for the current class, and then invoking any parent destructors to clean up inherited resources. The virtual keyword applied to a destructor has the same meaning as for other methods. The call to the destructor will be resolved at runtime. As you would expect, if a base class destructor is declared virtual, then the child class destructor will automatically be virtual. Here is the key takeaway from this talk. Let's use our prior example, where fruit is the parent class and apple is the child class. If we are deleting a child object, like an apple, and we happen to be using a pointer to the parent type of fruit, the fruit destructor must be virtual. If the parent class destructor is not virtual, then the destructor for fruit will be called, and nothing more, since destructors are invoked from child to parent. When the destructor for fruit is virtual, our call to delete will be late bound. The destructor for apple will be called, and then the destructor for fruit will be called. This is based on the rules of inheritance and the order of invoking destructors. So why is this so important? If you attempt to destroy an apple object using a pointer to fruit, and the destructor in fruit is not virtual, you have undefined behavior because the wrong destructor will be invoked. Data members of the child class may not be destroyed. There could be memory leaks. Perhaps if the data member is a lock, a mutex will not be unlocked. Here is another concern. If the apple object occupies more memory than the fruit object, the wrong amount of memory may be released, and this will corrupt the internal structures of your heap. As we mentioned, declaring the destructor as virtual in apple will have no effect and will not solve these problems. In order for the destructor calls to be correct, when using a pointer to fruit, the destructor must be marked virtual in the parent class. Marking every destructor as virtual is both unnecessary and expensive. However, omitting virtual when it is required means your code will not be correct and may have you be. Our suggestion is to actively consider if each method or destructor should be virtual as part of your design process. You should also add a step to verify virtual during every code review. For more information about CopperSpice, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back for our next video.